Question number 1 in multiple choice. Magnesium and calcium each form a compound with chlorine or compound with bromine. So we have here magnesium and calcium. Both of them, they are making compounds with chlorine or bromine. How can we detect this compound? So we give us some information. The element in group 2 with the higher first ionization energy. Okay, so in group 2 we have here the first ionization energy got decreased from up to down. So magnesium here, it has higher ionization energy. And the second information is saying the element in group 17, which is chlorine or bromine, with higher bond energy, QQ bond energy. Here it means the bond between the two atoms or in diatomic molecule is the higher. And we know that the bond energy got decreased from up to down. So here we are talking about chlorine and bromine, and the bond energy got decreased from up to down. So we are talking about Cl. So the reaction or the compound, it's between magnesium and chlorine. It will be MgCl2. So we should choose A. Thank you. Of two elements, X and Y. Element Y is in period 2 of the periodic table. So which element here in period 2? Carbon, oxygen in period 2. So it's one of the three. But he said in one atom of element Y, the B subshell has all three orbitals occupied. Okay, only one of these three orbitals is fully occupied. It means a pH orbital shell, it has 4 electrons. So 2s2, it has 2, and 2p, it has 4. So which one is oxygen? So we should choose one of the C or D. Then he said element Z is period 3. So both of them are in period 3, silicon and sulfur, both of them in period 3. But he said in period 3, the periodic table in one atom of element Z, the p subshell has only 2 orbitals. So it means 2s2, 2b2. So which one it has to be 2 is silicon. So it should choose C. Thank you. Question number 3. Glauber salt consists of crystal of hydrated sodium sulfate Na2SO4.XH2O, which can be used for the manufacture of detergent. When a sample of Glauber salt was heated, 1.91 gram of water was removed, leaving 1.51 gram of anhydrous sodium sulfate. Now we need to detect X. Actually, we should find the ratio between the anhydrous salt and the amount of water which got removed from this amount of salt. From the stoichiometric of this compound, we can understand here we have number of water molecule which is related to combined with 1 mole of sodium sulfate. Actually, we should find the how many moles are in 1.91 gram of water and how many moles are in 1.51 gram of sodium sulfate, and find the ratio between them. How can we find the number of mole? As we know, the number of mole equal the mass over molar mass of each. So the mass number of mole in one case of water equal now 1.91 over 18, which should equal 0.106. Okay, in case of anhydrous salt, it's equal 1.51 gram divided by molar mass of sodium sulfate, which is 142. After calculating, should equal 0.016. So from this ratio, now we have two numbers, 0.016 and the other number is 0.106. The ratio here is, it can be 1 to 10. It means the 1 mole of sodium sulfate, it needs 10 moles of H2O. So X here equal 10. So should choose C. Thank you. Question number 4. What contains the greatest number of the named particles? So the number of particles here, it depends on the number of mole multiplied by the Avogadro's number, which is a constant. So according to the number of mole, we can detect which has the number or the greatest number of particles. So we should find the number of moles in each. Here in the first one, 6 dm3 of argon. So this is a volume. So we should choose the formula of volume to find the number of moles in argon because it's a gas. So number of mole here equal 6 dm cube over 24. Okay, to find 0.25 mole in this volume of argon gas. And the second one, so here the number of moles is 0.25. The second one 6.0 gram of carbon dioxide. So here we should choose the mass formula. The 6 gram divided by 44, the molecular mass of carbon dioxide, give us 0.13 mole. Okay, the third one, 6 gram of magnesium atoms. Here the 6 gram divided by 24.3, the molecular mass of magnesium, equals 0.246. So this is number of mole. And here the last one is water, which is 18.6 divided by 18 equals 0.33 mole. So the maximum number, or the most or the greatest number of mole is 0.33. So water here, it has the most number or the greatest number of particles, because if we take this number 0.33 multiplied by the 6.02 times 10 power of 23, it will give you the greatest particles number. So the right answer or the correct answer is D. Thank you. Question number 5. Phosphorus forms a compound with hydrogen called phosphine, pH 3. This compound can react with a hydrogen ion H positive. So pH 3, as we know, it still has pH 3, is phosphine. Phosphorus here, it still has lone pair of electron. This lone pair of electron, it can react with a proton of hydrogen. Okay, and this proton of hydrogen, as we know, it's empty from any electron. And this kind of bond, is covalent bond, is called dative bond, as the two electron source came from one element, not from both of the two elements, and the other element should be empty, or it has at least one subshell empty. And these conditions are available here in this question. This is H plus, and here's this phosphine, and the kind of this bond is called dative bond. So the right answer is A, dative bond. Thank you. Question number 6. The graph shows trends in four physical properties of elements in period 3, excluding argon, which graph has electronegativity on the y-axis. So we know the electronegativity in periodic table trend increase from left to right side. So here in period number 3, sodium, it has less than magnesium, and magnesium, it has less than aluminium, it has less than silicon, and so on. So the chlorine here is the most electronegative element, and sodium is the less electronegative element. So the right answer is D, as this graph shows the correct answer. Okay, so the electronegativity trend in periodic table increases from left side to right side. It's a fixed trend. Thank you so much. This is the electronegativity trend. The question is number 7. The element 10 exists in two forms, gray and white, as we know. Now we need to see some information about both of them, the gray one and the white one. This is a boiling point. Okay, this is a 2543, here's 2533. There is a very small difference, so we cannot detect anything about from the temperature, but electrical conductivity here is none in case of gray, and in case of white, it has good in solid and liquid. The malleability is brittle, and here is malleable. So the structure changes might take place when gray 10 changes to white 10. So if the structure changes from gray 10 to white 10, so what's the structure change here? What's the kind of change? Is it giant covalent to giant ionic, or giant covalent to giant metallic, or giant ionic to giant covalent, or giant ionic to giant metallic? As we see here, for the second one and the third one, electrical conductivity, non-solid, it's none in solid or liquid, and converted into good in solid and liquid. So here it means this is a giant, as it has high boiling point. It's a giant covalent to be giant metallic. Okay, and we can confirm that from malleability, as here is brittle, giant covalent, and that one is malleable. So the change in structure here is giant covalent to giant metallic. B is the correct answer. Thank you. Question number 8. Which solid has a simple molecular lattice? Here we have calcium fluoride. This is ionic compound. Nickel, it's transition metal. Silicon oxide, it's a giant covalent. And then sulfur, it's non-metal. So which one here, it has simple molecular lattice? Actually, it's sulfur, because the first one is giant ionic, second is transition metal, it is giant metallic, and here silicon, it's giant covalent, and sulfur, just sulfur is, which is S8, as we know, 8 atoms of sulfur, they can bind it with each other with weak van der Waals forces, okay, to give us the simple molecular lattice, which is sulfur. Okay, thank you. Question number 9 is the standard enthalpy change of combustion of carbon is this number, and he gives us the standard enthalpy change for combustion of hydrogen, it is this number, and the standard enthalpy change for formation of butane is this number, and he needs the enthalpy change of combustion of total butane. So first of all, this is a combustion enthalpy change question. We should write the equation to understand what should we do. The equation for the combustion of butane is C4, composed of C4 and hydrogen Zr10, okay, plus oxygen in complete combustion should gives us here 4 carbon dioxide. Well, how did I know they are 4? Because here we have 4 carbons, plus how many H2 we have here? Because we have here 10 hydrogen, so they should be 5H2O. Now from the number of oxygen here, we can detect how many oxygen we should use in complete combustion. In product, we have 4 times 2 Zr8, and here 5 oxygen, so all of them are 13 oxygen, so it will be 13 over 2O2. This is the equation of combustion, and we need to find the enthalpy change of this combustion. And he gave us some information. What are this information? He said the butane combustion, okay, composed of carbon and hydrogen, of course, carbon combustion. How many carbons do we have here? We have 4 carbons. So 4 carbons to make combustion for 4 carbons to give us carbon dioxide. It can give me carbon dioxide with enthalpy change minus 394 kilojoule. But how many carbon do we have here? We have 4. So it should be 4 times minus 394 kilojoule. Okay, and the hydrogen, how many hydrogen do we have? We have 10 hydrogen, which they are 5H2. To make a combustion for 5H2, it needs how many kilojoule? The enthalpy change, it's 5. Why 5? Because here we have 5 moles times 200 minus 286 kilojoule. These are what? This is the combustion of carbon and hydrogen separately. Now what do we need? We need to find this enthalpy change. And also he provide us with the formation of butane enthalpy change, which is minus 129 kilojoule. So the butane, they can got performed or got formed from carbon and hydrogen by this enthalpy change, which is 29 kilojoule per minus. Now what do we need to find? We need to find this one, as we don't have it. So now we will write the equation. This is a graph of Hess law to detect what? To detect the enthalpy change. Okay, so how can we find this enthalpy change now? The enthalpy change equal what? Do we have here this direction? So to write the equation or to write the calculation, the delta H combustion of enthalpy change for butane C4H10, okay, equal what? Equal 4 times, first 4 times minus 394, because this is the first one, okay, plus how many hydrogen do we have? 5 multiplied by minus 286, okay, all of them minus 129 kilojoule. It will give us the result here. If we finish this calculation, it will give us minus 1576 plus minus 1430, okay, minus it's plus 129. At the end, the result, it should be minus 2877 kilojoule per mole. Can we find this answer in our options? Yes, we have it in, B. Okay, so the right answer here in question number 9 is B. The question is, the processes are described here. We have three processes. The first one is hydrogen with OH, so this is neutralization reaction. Second one is CH4 with carbon dioxide. It's combustion reaction, and here we have NH3 gas to give NH3 liquid. So this is condensation reaction, and the question is, which statement is correct? None of this process have a positive enthalpy change. Endothermic hemine, endothermic reaction. Let's check. Okay, only one, only two, only three are endothermic. So he's asking here about which reaction is endothermic reaction, gives us a positive value as enthalpy change. Actually, the first reaction, as we said, it's a neutralization reaction, and the neutralization reaction is exothermic reaction. Second reaction is combustion. Also, combustion reaction is exothermic reaction. The third one is condensation reaction. Also, it's exothermic reaction. So no one from these three processes are endothermic reaction. All of them are exothermic reaction. So we should choose the option A. None of the processes have a positive enthalpy change. That one is correct.